Hi, fifth graders. Welcome to your lesson on finding the volume of a composite solid figure. A composite solid figure can be made by putting two or more rectangular prisms together. And we don't have a specific formula for finding the shape of the entire composite solid figure. So we need to decompose or break apart that solid figure. So here is the figure as a whole. And there's no numbers we can plug in using the 9, the 15, the 5, the 3, and the 3. That's going to get us to the volume of that shape. We are going to need to either break it apart like this or break it apart like this. And you can see that the book has broken apart those two rectangular prisms by color. So one of them is now blue and one of them is gray. And it doesn't really matter which way you break it apart, but the key is going to be finding the numbers that you need to use to make this work. So I'm going to start with the first or top composite solid figure. That is the one with the blue rectangular prism going up and down, going vertical. Now, this shape, we can see 5 visible numbers, but you're actually only going to use a couple of those numbers to help you solve this problem. You can see that they have us listed as 2 different types of volumes, and one of them is going to be for the blue box and one is going to be for the gray box. Let's start with the blue box and we'll call that volume 1. So just like our regular rectangular prisms, guys, we need to find a length, a width, and a height. So as we look at the blue box, we can definitely see that as a height, we have the number 9, vertical arrow going straight up and down. We should also see that up here at the top, we have a length of 3. So that should go in right there. And the only number we're missing at this point is the width. And we don't really have a width shown on this box as we look at just the blue, but what we know about rectangles is that opposite sides of a rectangle are even. So the width, which would be this line right here, should be the same as this line right here, which is also the same as this line right here, which I've just crossed it out now, but that shows us that that line is now a 5. So we've got all 3 units of measurement for our blue box. So I'm going to erase now and get rid of the lines on there so we can see that first one is done. Now, here's where the tricky part comes in. For the gray box part that we are looking at right here, you're looking at a situation in which you see a 15, a 5, and a 3, and you automatically assume that those are the 3 numbers that we need to use. The 3 is definitely the height, and we can for sure write that in here. And the 5 is still definitely the width of that box. That has not changed. But where the length is, we cannot use the number 15. The reason we can't use the number 15 is we've already used this small section of blue box. And we determined that that was 3 inches when we created our first rectangular prism measurements. So that means I need to take the 15 and subtract the 3 to find that we have a length, or a length in this case of 12 for that rectangular prism along the bottom. So those should be the 3 numbers for each box that we have, and we'll tally them up, and you can go through the process, and it doesn't matter which numbers we multiply first. Again, if you remember correctly, whenever we have multiplication taking place, we can multiply them in any order. So 3 times 5 is 15, times 9 gets us to, writing with my finger, guys, so bear with me, 9 gets us to 135. So we should know that the area of that first box is 135. Now, the second box, again, I can do any order in which I want to. I'm going to erase this first work here that I had and go to the second one. And we've got, I'll start personally with 12 times 5 because that's relatively easy for me and get me to 60. And then I can see that I still need to multiply that number by 3 to get to 60 times 3, which is 180. So now I know that my second volume, or the volume of my second rectangular prism, is 180. And if you look below my chicken scratch here, you can see that we have a total volume problem, so to speak, and we would take the volume of rectangle 1, rectangular prism 1, which is 135, and we would add it to the rectangular volume of the rectangular prism number 2, which is 180, and we'll add those two things together to come up with our total answer. So in this case, 315 should be our answer. And again, remember to label it, which they've already given us here, of cubic units, or cubic inches, excuse me. We are still dealing with volume, so that is where that's going to come from. So again, kind of messy on my screen right now, trying to write with my fingers, so I'm trying to figure out the best way to make this work, guys, but hopefully it will work for us. Now, the same thing would apply, and I guarantee we will end up with the same answer on our bottom section here, guys, if we choose to go with the horizontal blue rectangle first. It doesn't really matter. Just trying to make sure that we end up with 315 and that we don't overuse numbers. The key part of this whole problem, guys, is always the corner that's going to overlap. So if we look at this section right here, technically this little area is going to be incorporated just like it was in the last one in both boxes. And so that makes it really, really difficult to solve this problem unless we kind of physically break it apart. Okay, so again, I'm going to erase this, what I've got written on there. Go back to the drawing table here, and I'm going to start with the blue one this time, which is on the bottom, which we started with the last time with the blue one, but the numbers were different. Now this time we can use 15 as our length because it goes the entire length of the bottom. And we can use 5 as our width, and we can use 3 as our height. That stuff should all work because those lines are true right here, 15, 5, and 3. That is a full rectangular prism. All right. Now we need to take a look at the second rectangular prism, and this is again where we're going to need to use a little bit of common sense and a little bit of knowledge of what we know already about rectangles to help us with this process. So we would again look at the width, which is 3, where we had 15 over here. This is going to only be 3 now because we can see this area up here is 3 inches. We should also still know that this area across here is the same as it was before, so that's going to be a 5. But the height is again where we need to do a little bit of subtracting. I have a height of 9 all the way from the bottom of this piece, but I can't use this section down here. So I have to subtract the height of 3 from that piece. So actually the height of this rectangular prism is only 6. So now, again, a little easier math for that second rectangular prism, the volume of that second one, but the first one should be pretty straightforward. Okay, so 3 times 5 gets me to 15, times 6 gets me to 90 is my volume for the smaller rectangular prism. Okay, and now the top rectangular prism, again, a little bit harder, a little bit more difficult because we are using some bigger numbers here, but I'll clear out our space and get us an opportunity to try and identify what we're doing here. So again, any order that you want. If you want to get it to be 15 times 15, that's fine, since 3 times 5 is 15. So I'll just go 15 times 15. And remember, you guys are allowed to use your calculators. I'm just doing this off the top of my head here right now. So make it work and show you how the process is working here. Okay, so 5 times 5 is 25, carry the 2. This gets us to be a 75, 0 placeholder. I'm not done with that 5. 5 times 1 is 5. 1 times 1 is 1. And I've got my new problem here, which is 225. So now I've got my volume of my second rectangular prism as 225. Just like on the first one, I'm not done yet. I need to finish the process off by taking the two combined volumes and add them together. And if I do that, I should end up with my 315 like I ended up before. 5 plus 0 is 5. 9 plus 2 is 11, carry the 1, and I still ended up with 315. So hopefully, guys, that explains a little bit to you about what is happening there. What I would like to do, though, is I'd like to go through one more with you and get you to understand what it is that we are doing now that we don't have the visual of the blue and how that's working out for us. So, sorry, this erasing is taking forever as well when you get using your finger to do it. So hopefully this will go a little quicker. All right. So now if we look down at the bottom here, guys, I'm going to scroll up just a little bit. Nope, I'm not. I lied. So if we look at, let's take a look at number 5, actually, just because those are smaller numbers and we can make that work a little bit easier. You should still be able to see the 2 rectangular prisms there pretty easily. Or if, in all honesty, if you wanted to look at this as 3 separate, you could break the lines up going this way. I personally think I'd rather only do 2 of them just for the simplicity of having to only do 1 or 2 formulas. So personally, I would break that apart at that spot right there. The first volume, we could do the small one or we can do the big one. I'm going to start with the big one just because I like to get the more difficult aspects out of the way. So this one should have a height of 3 times a length of 14 times a width of 5. Okay, 3, 14, and 5, my 3 dimensions. Again, finding volume, I always have to have 3 dimensions. All right. Then, now I'm looking at the smaller one. Now this is going to be a little bit more challenging for us for the simple fact that we again are missing one of those numbers, but hopefully we can figure it out relatively easily. They have shown us that the length should be 4. They have shown us that the height is only 2, so a nice small number for us to work with. And in this one, we are still looking for that width. We are not sure what the depth of that is. But again, if we remember correctly, the first one was 5 right there. And what we know about rectangles is that opposite sides are equal. And if we continue that process up through here and over to here, we end up realizing that that should also be a width of 5. So those are my 2 formulas that I need to solve. And again, remember you guys have access to a calculator here. So just make sure in this one we don't actually have any double ups because it's a little bit easier layout for us. But as we take a look at this, the first one should get me to 5 times 2, which is 10, plus 4, or times 4 is 40. So my first volume for this one right here is 40. And this one up top here, again, depending on how I do it, I'm going to suggest that we combine the 5 and the 3 and get this to be 14 times 15 and solve it out that way. Again, guys, I apologize for the mess trying to do this with my finger. Yeah, of course. And now I'm ending up there. So as I get this one done, 0, 11, should be 210 is our second volume. And now we end up with 250 as our total volume. And again, remembering that we are going feet cubed because it is 3-dimensional shape, or we could go cubic feet. All right, so now that the video is over, guys, and I know it is a challenging problem, I'm not going to deny that for you, but I'm only going to ask you one question on this to solve this problem, and that is question number 4 on the bottom of this page. So I will put an exit ticket or a question on there that simply says, please find the volume of the composite solid figure for number 4 on page 371. And put your answer in. Again, we know this is the first time you're going to be attempting this by yourself. We do not expect perfection, and there will be another lesson or 2 on this idea. So don't feel bad if you get it wrong. Do your best to try and complete it, and then hopefully with some more practice over the course of this week, we will figure out this process. Thanks.